Alright, so I wanted to start off today with communicating what you needed to do in the event that you're wanting to possibly drop or lower down from an AP class. So real quick, I sent this form out to you and your parents that shows the process. Okay, there are steps to this. So if you are interested in possibly wanting to do this for whatever reason, please make sure that you get this done ASAP as it is due this Friday on September 20th. Okay? Another thing is we have a grade check this Friday. So I did email several people over the weekend saying, you haven't turned in forms, this is the forms that you're missing. Or even emailed people saying, making sure that if they're new to the class, to make sure that they get caught up and so on and so forth. My point is, please make sure that you're doing your part and making sure that you're checking skyward so that everything is good to go for this Friday's grade check for sure, because this does affect eligibility. Okay, this Friday check does affect eligibility. Alright, so let's go to today's date. So we have the 16th right here, day 3. You just did your warm-up. We're going to do a CFA here in just a bit. We have a linear programming handout that we're going to go over. And right here, we're going to go over checkpoint 2. And checkpoint 1 is due the next time that we see you, that I see you, okay? So please make sure that you go to, on the calendar, wherever you need to find checkpoint 1, which is right here. And you're going to click on it, and you're going to be able to see and print this off from home and see what does the project entail, okay? And a lot of what we do, especially today, is the project. So if you can understand today, the project is not as difficult as it may seem, okay? A lot of what we do today is directly related to the performance task. Okay, so let's go to the other thing that we're going to do is I'm going to show you in Desmos of how you can graph functions. I'm going to show you in your calculator how you can graph functions. This right here is optional for extra practice if you'd like to. It won't be taken for a grade. And the two big questions that we're going to ask today are, when is zero or negative number an inappropriate answer to a problem? And why is linear programming a good way to solve a real life problem? So what we learned today definitely has a lot to do with these real life problems that we're talking about. Here, I will replace that video with what we do today. Okay? Over here, I will have a video that shows and basically talks you through your project. What your expectations are, the due dates as far as the checkpoints and so on and so forth. I'm going to record that with you, and I'm going to link them right there. Are there any questions so far of what we're going to do today? Okay, so let's go ahead, and I'm going to pause the video for now. We're going to take this CFA 2.2 right now, and you may use a calculator if you want, definitely, to check your answer for sure. But we're going to do 15 minutes on this CFA. Okay, so we just finished the CFA, and just a reminder, guys, today's CFA, you can locate the answers right here in 8th periods. So here's the key. And I did have a couple of questions on the CFA in regards to when is it flipped as far as the inequality symbol, and it's all about this right here. So I had a negative 3y was less than or equal to all of that equation. And any time throughout the process that you're trying to ultimately get y all by itself, if you divide by a negative or multiply by a negative, that is when you switch the inequality, okay? You flip it. If you don't, you can subtract a negative, you can add a negative, you don't flip it. It's only if you multiply or divide throughout the process. Okay? So that's that. That's it on that. Let's go back to our calendar. And we're going to look at Desmos here in just a bit. I'm going to ask Elijah if he can help me with Desmos. I'm going to quickly show you how you can graph this in Desmos, and also show you how you can graph it in your calculator, okay? Because it will help you tremendously on your project as far as figuring out what we're talking about today. Alright, so in Desmos for inequalities, we're going to look at our notes of linear programming. So please go ahead and grab these notes out. And what we're going to do quickly is we're going to find how did they come up with this answer right here? And the answer is the shaded region. We're going to figure out how did they come up with that shaded region answer, both with Desmos and with the calculator, okay? So first let's use Desmos, okay? So we're going to use it for these equations right here. So you have it in front of you. I'm going to take a quick picture so I can help Elijah input this in. And just like we see it, we're going to put it into Desmos. Here we go. So start graphing. And we're going to write, go ahead, Elijah, we're going to do x plus y is less than or equal to 16. Right here, notice where he's going and clicking. There's my less than or equal to inequality symbol, and I'm going to put 16. Okay? And look, he's zooming out so that he can see. This is the line that I just graphed. Okay? Now, before he moves on, before he keeps going, we need to know how to do this by hand because our quiz is going to be non-calculator and as well calculator. Okay? So if we're doing this by hand, we're going to get y alone, and it looks like this. All I did was subtract x over to the other side so that I could get this equation. Notice the y-intercept is at 16, and notice that the rise over run is a -1. Finally, notice that I graphed and shaded everything that was below or equal to that line. Are we good? Any questions? Okay, so let's keep going. We're going to put in our next equation. And our next equation, Elijah, is 3x plus 6y is less than or equal to 60. Oops. There you go. 3x plus 6y. And notice him finding that inequality symbol there at the bottom. And then 60. And there's our shaded region. The double shade right now is our current answer. Okay? It's our current answer. Now we're going to do x is greater than or equal to 0. And y is greater than or equal to 0. And with all that, guys, I know it's a little bit difficult to see, but zooming in kind of helped a little bit as far as seeing where that shaded region lies. And what we're going to learn today is that our answer is the intersection of all those regions. So let's go back to this notes page right here, and you'll see that right here at the very, very bottom left. Okay, so let me go ahead and highlight it for you. This right here is what we just did. The most important thing from that is we're going to look at the corners of this shape. Today, it's all about the corners. Okay? The corners are key to this, the whole thing, okay? The corners will tell us when something is maximized or minimized. Things that we want to maximize in life. Maybe financial, profit. We want to maximize profits. We want to minimize cost. Let me give you some other analogies. Let's say that I'm a surgeon and I'm trying to maximize nutrition with a patient. Or I'm minimizing, and I'm talking about this on a genetic scale, like biology. Okay? And I'm trying to minimize the size of a brain tumor. So there's certain things that I have to use and things that I have to do to make these things happen. Other examples. Let's say that I work for Raytheon or Lockheed, and I'm trying to build the next fighter jet. And I have 60 million to make this work. What I want to do is minimize possibly surface areas on the ship. I want to minimize costs. There's a lot of things I want to minimize, but at the same time, I want to maximize torque. I want to maximize banking. I want to maximize the strength of a wing under 8 Gs. So what we use today, there's a lot of application for minimizing and maximizing functions. And the next time you see it to this level, it's probably calculus. Okay? So, the corners. When I'm looking at the corners, I'm looking at the corners of the shaded region. Okay? And those corners are listed right here. 0, 0, 16, 0, 12, 4, and 0, 10. And you could see A, is right here. Here's B, here's C, and finally here's D. And if I plug these values in, I find what they're called critical points. I find these values and I plug them into this function that I'm trying to maximize. I'll plug in 0 for x, there's x. I'll plug in 16 for x, 12 for x, so on and so forth. And I'll also plug in the y values where y goes. Here, here, and here. And what I'm trying to do for the corners, and the corners only, nothing else matters per se. The maximizing or the minimizing will only come from the corners. Okay? So like if I had a point right here, it's not important. Here, 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 it's not important. It's only at the corners. And these are my extremes. And you can see the maximum was 180. And you see it written at the very bottom of your notes. And the minimum was 0. Okay? So here was the minimum. We say that the minimum is 0 when x is 0 and y is 0. Here is the maximum, and we say that the maximum is 180 when x is 12 and y is 4. So for the quiz, for the test, whatever it is, you're going to be writing things now in a kind of a semi-sentence notation. Okay? Questions so far? Okay. So, how do we find these points is what it's all about. Okay? So, there's many ways that you can find these points. Let me show you a couple. First of all, you definitely want to make notes of this right here that I'm about to show you, because this is by hand and with a calculator. Some of you do things differently, and how you set this up is going to make or break you as far as in the fact of, is it going to be easy to interpret or is it going to be a little bit difficult? So let's do the by hand first. So by hand, what you can do is you can get basically solve for y equals mx plus b and graph by hand. You know this from Algebra 1. Go to the B, do the rise of the run, draw it, and shape. Another thing that you can do by hand without a calculator is if you're solving two functions when they're equal to each other, you can do elimination or substitution. Okay? With the calculator, I'm going to show you a lot today with the calculator. And we just saw with Desmos. Desmos kind of makes it easy for us as well to visualize when those lines are happening and the shading is happening. So, over here, the first one with a calculator would, of course, be by the graph. Bless you. So the normal graph, okay, that's definitely like the points of intersection we can see, and we've done that earlier this week. The other one is menu 371. This one was the systems of equations. The one that it looks exactly like your paper and it just gives you an answer. Or it gives you false. Or it gives you that weird C answer. Okay? And then the last one, here's what I'll say with the graph. The extension that I will show you today is relations. Relations don't have to pass the vertical line test. And I'm going to show you here in just a bit of how you can find them. So now, let's go back. How could I find C? Which two equations would I use to find C if I was doing it by hand? What would y'all say? What's one of the equations that I could use? Let me scroll down just a little bit so that you can see this. All right, so we're gonna look for C. We're trying to find this intersection by hand. Which two equations could I use out of these four right here? The third one? Not the third one. The first one, which is right, remember the first one was right here? And then the second one is right here. So these two equations, I'm going to show you how you can solve it by hand, okay? First of all, you can either use elimination or substitution, which I think are probably the best ways. Or we can get y by itself and make these equality problems. So we get negative 1/2 x plus 10. And I could set these equal to each other. So I get negative x plus 16 is equal to negative 1/2 x plus 10 and solve for x. You with me? If I solve for x, I would get 12. And I could plug that back into any one of these equations to get y, which I would get 4. So I just showed you 3 ways of how to do it without a calculator, okay? Now, let's do it with a calculator. So solve feature is the third one. What I'm going to do is I'm going to take a picture of this right here, and I'm going to tell it to solve. Here we go. Solve for x in all of this mess, if you will. Okay? So with me, let me take a picture of this real quick, and then we will go through it together. And I want you to see the steps. And if you get lost, again, just sit there, look pretty, and we will be able to see this on the video later, just to make sure we know how to get it. I want you to just pay attention as we go through. All right, here we go. So I'm signed in. Let me show you real quick on mine. And follow me closely, please. One for a new document, and one to add a calculator page. And we're going to set that thing, that solve feature that I just took a picture of, by the following. Menu 3.1. And we're going to solve, when is negative x plus 16 equal to, and the equal sign's right below the control button. When is it equal to control divide a negative 1/2 x plus 10? And I'm going to do comma x. And you see, you get it at x is equal to 12. Remember, we said we had our point was 12. Okay? So if I go back over here, we have 12,4 as that point that we were finding right here. Okay? Now we're going to take that 12 and we can put it in any one of these functions right here, any one, to see what would I get. So if I put a 12 right here for x, I'd get negative 12 plus 16, I get a 4. So that's the solve feature, okay? Now, let's do it a couple of other ways just to refresh you. I'm going to do it with the menu 371, solving systems of equations. Let me do that again. Menu, algebra, solve system of equations, and we're going to do number 1. We press enter, and now we're going to make these two. We could say their original thing, x plus y, this is very, very important, equals 16. I know it says less than or equal to, but we're not going to put that right now. We just want to find where are these points equal to each other, okay? So the second equation will be 3x plus 6y is equal to 60. And guys, you see it very quickly that it finds for you where those corners are. Okay? That's a way that you can find it with a calculator. The last way with a calculator is by the graph. So add a graphing page. We have to get this in y equals mx plus b form. So here we go. Negative x plus 16. And our second one is control divide negative 1/2 x. Whoops. Control divide negative 1/2 x plus 10. So now, it's off to the side, you can't see it. It's menu, zoom, that's 4. And we're going to zoom out, so that's 4 again. I'm going to say that the center is here, and I zoom out. And now you can see that there's 12,4 possibly. And we will do menu, analyze graph, analyze the intersection, and now I just have to soft mouse scroll this thing anywhere to the left and press the keypad. then it'll say what's the upper bound, and I want to soft mouse to the right, and you see it pop up as 12.4. If you wanted to move it, yes, you can grab it and hold the button until the hand closes, and you can move this like up here if you like, so you can see it better, and then let it go. All different ways, both by hand and with calculator. The last way that I'll show you with calculator helps a lot with what we're doing today. Okay, here we go. Everyone from here, press delete 3 times and say yes. Press menu, window, standard. And now from a good center point, we're going to show what the shading can look like with Desmos, but on this graphing calculator. Okay? And if you learn it, use it. Here we go. And I actually just realized this today. I didn't realize that you could do it, and I saw it today on the calculator, and that's why I'm recording it. Here we go. Tab. We're going to say menu. We're going to do graph entry with 3. Okay? So this one, right here, the equation can be, the equation can actually be a relation. It doesn't have to be a function per se. So those of you who pressed yours on yours, do you see a relation right there? Does it say relation? Okay, so if it doesn't, I would say home to, menu C, okay, okay, and then 1, 1, add a page, make it 2, and then try again. Okay, so if it doesn't show a relation this time, it might be because it's needing the newer software. Yeah, and that's probably what it is. So yours has the newer software, okay? And I want you to see what this looks like. That's why I'm coming over here, and I'm going to grab this calculator real quick and sign in. No worries. All right, so let me go ahead and pull up my new calculator that I just signed in on. All right, here we go. 1, 1, control out of page, 2, and here we go. Menu, graph entry, there it is, relation. So now you don't see F1, you don't see F2, you see a relation. Relations can fail the vertical line test. Okay? So I'm going to go to my original problem and I'm going to put x plus y is less than or equal to. Look at how I found this button. It's control equals. And I'm going to do less than or equal to 16. And immediately it will not only graph it correctly, but it'll shade for you. If you need to zoom out, just menu 4, and enter, and zoom out. You see this equation is way up here, guys. And if you want to zoom out a little bit more, you can again. And then just press escape when you're ready to be done with zooming out. Watch how I grab this equation. Press and hold the keypad, and you can drag it anywhere you want if you want to move it out of the way. Here we go. Press tab. Here comes relation 2. 3x plus 6y is less than or equal to, that's control divide, and it's 60. If we did that, you see where this other equation is, and it's in my way, so I'm going to press and hold so that I can move this off to the side. Okay? And then I have a couple other ones. I have x is greater than, so tab, x is greater than or equal to 0, and press enter. You see it right there. It's shaded everything to the right of the y-axis. And then last but not least, we have y is greater than or equal to 0. So y is control equals greater than or equal to 0. Now I know this one might be a little bit more difficult to see the answer. But with all that shading going on, if I shaded it very well on my calculator, you're going to see that it ends up becoming this answer. Oops. Make it a little bit more predominant. This answer right there. And the corners we can find by doing the analyze graph intersection with the calculator if we choose to. I just showed you a lot. Are there any questions right now? By hand, with calculator, all craziness. Are there any? Yes?
What was the other two that you put in were just the x is greater than or equal to 0 and y is not greater than or equal to 0?
Yeah, so relation 4 is y is greater than or equal to 0, and relation 3 was x was greater than or equal to 0. Okay? Any other questions, guys? Because it looked like the shaded region that we have in our notes. We good? Alright, so now we're going to get 6 points, possibly 120 points if you're perfect in teams. And what I want you to do is I want you to come up with these functions right here. Okay? These 4 functions we're trying to maximize and minimize. So find the corners, find the values exactly the way it was written here. Thank you for your help, Elijah. Exactly the way the previous answer was written, I want you to come up with this, okay? Work very well together, push each other, make sure that you are doing it both ways, non-calculator and calculator if you need that extra help. But your goal, guys, is to maximize and minimize that function and to draw it right here, okay? And I'll give you 8 minutes. Alright, so I'm going to show you something real quick just to help you out with what you're doing. If I wanted to find the intersection between these two right here, I'm going to first of all write them down but with equal signs. Oops. So now when I use my system of equations in my calculator, that menu 317, all I have to do is type this out. Okay? So let's go back to the calculator and you see that I just did it. So menu 317 will get you to that solving systems of equations. We press enter. Yeah, 371. And then I'll do x plus y is equal, even though it's an inequality, I'm setting it equal so that I can find when are those corners happening. So I could do that for the first 2 equations. I could do that for the second 2 equations. I could do that for the third 2 equations. And last but not least, I could do it for the first and the last equation. This will tell me what points that they're lining up at. And all of those 4 points that I got, I'm going to plug in and test these values in this function. So I'll plug in this point here into this equation and see what is my P equal and write it down. I'm going to do it all 4 times so that I can see which one of these points or corners will be the max and which one will be the min. Now listen, if you get an error, which some of you might get an error on the calculator with menu 3.1, it's because you're probably putting these in as inequalities. So if you get a weird error, you can't put them in with inequality symbols. Make them equality because you're just trying to find the points of intersection. Are we good? Okay, so let you get back. Alright, so now the video is resuming. What we're going to work on first is we're going to find how to do this so that you're ready for the quiz on Wednesday by hand. So let's go back over here and we're going to graph these 4 equations over here by hand. When doing that, this is why we did y equals mx plus b so many times. I'm going to graph this equation. Notice how I solve for b. Solve for y. Get y all by itself. And this one over here would be y as less than or equal to x. This is still y is greater than or equal to 0. Now if I go over here and I start graphing this by hand, it would be a positive 2 with a negative 1 slope, down 1 over 1, and it would look something like this. Okay? And we're going to graph everything that is above this line. Okay? Next one we have is y is less than or equal to x. So we know y equals x because we did inverse functions. Remember when we were reflecting across this. And we're going to shade everything that is below this line. And you already start seeing the double shaded region. So far right now, and I'm going to erase it here in just a bit. So far right now, this is my answer region. So far. as you go, you want to shade and keep track of what is your answer and where is your answer region. Alright, so let's go back. And now let's do our third function, which is x is less than or equal to 4. So x equals a number is a vertical line. It's not dashed because none of these are just strictly greater than or equal to, or sorry, greater than or less than. So I'm going to go at x is equal to 4, 1, 2, 3, 4, and I'm going to draw a vertical line, and you tell me, what direction do I shade? Left. And x is the only one that's left and right. If there's a y and an x, you're still thinking about top or bottom. Okay? Now my running answer is right here. Oops. It's right here. The last thing that I have to do is just y is greater than or equal to 0. And that will bound that last piece right here at the x-axis. Y is greater than or equal to 0. So I'm going to shade everything above. So now I see that my answer is that right there. Now I'm going to show you how to find these intersections by hand and with the calculator real quickly. And then we'll move on to our word problem. Alright. Guys, just looking at the graph, what is this? 4, 0. Just looking at the graph, which one is this? 2, 0, right? Now, just looking at the graph, this kind of looks like it could be what? 1, 1. And looking at the graph, we know for sure which one of these two values. 4, x. X is 4. So here we go. By hand, I want to see what this y value is right here. So what I'm going to do by hand is I'm going to set this equal to this and kind of make sense of it. You with me? So this x is equal to y is this line right here. It's that line. So if x is equal to y-ish, and I know that the x value is 4, then what is my y value? 4. And 4-ish, right? And I know it because of the equation. And I said ish because it's an inequality. Any questions on how I got that? Okay, so now let's look at this equation, which is y equals x, and this equation, which was negative x plus 2. And what I'm going to do by hand is I'm going to find, when does this function, which is x, equal this function. Here we go. So, when does x equal negative x plus 2? Well, all I have to do is move the x and solve for x. And when I add it over, I have 2x's is 2. If I divide by 2, what do I get, guys? X is 1. Now I know this one for sure. Okay, this one. Now, if I want to find what the y value is, after that I found my x value intercept, or intersection, I can find this simply by taking this one right here that I found and plugging it into any one of these functions. Either one. And it will give me this y value right here. You with me? That's how to do it by hand. Now with the calculator, I would suggest this. Do the system of equations, menu 3, 7, 1, and you're going to do them 2 equations at a time. Doing the first 2 first, making it equals, or you will get an error. So do these 2 first, then do these 2 second, then do these 2 third, and then do those 2 last. And you can find all of the intersections that they have. You with me? Okay? And those will give you those corners that we got by the graph or by hand and the way that I showed you on the last video or recently as far as on the graphic goes. Are we good? Okay, I showed you how to graph these already as functions or not. No, I showed you relations, right? So, real quick, just for the practice so that you guys are well versed, I'm going to do these, a couple of them, just to show you what it looks like. Please follow me. Go to your graph. We're going to press delete 3 times. Whoops. So you have to escape and make sure that you don't have y equals or a relation popping up. Press delete 3 times and press yes. Menu, zoom, standard, because I always like to start from a nice clean standard. And now we can start putting these in as relations. So tab, x plus y is greater than or equal to 2. There it is. X is greater than or equal to y is coming. We'll press tab, x is greater than or equal to y, and there it is. Now I'm not going to finish this because we already know what the graph looks like. I just wanted to show you with this. Let me show you. Grabbing this equation, moving it out of the way, grabbing this equation, and it's all color coordinated for you, moving this out of the way. If I wanted to find where those two were intersecting, this is how I could do this. Menu, analyze graph, intersection. And the lower bound can be somewhere to the left, and scroll over soft mouse, and there's the answer 1, 1. I've shown you a lot, guys, a lot. Please, if you need to go back and watch this video, by all means, do so. Okay? So now what I'm going to do, I'm going to stop the video, and then I will restart how to do that word problem. In case we don't finish, at least this is closed. And at the same time, you'll have that third video that shows you instructions for the project. Are there any questions before I stop this video, though? Yes?
How did you get the 1, 1 up there again?
By pressing menu 6 to analyze graph and then intersection. And now look at the bottom left, it's saying what's your lower bound. So you just have to be to the left of that point and then press down on your keypad. Then it will say what's your upper bound after that, and then you just scroll to the right and it'll pop up 1, 1. We good? Okay.